okay? Anything that you can see or count. So 1, 2, 3, dot, dot, dot. Based on that description, no negatives and no zero, because you can't see zero of something. Okay? That is the centermost portion of the what they call Venn diagram. Now you know as well as I do that that's not the only number source we deal with in the universe. We also deal with zeros and opposites of these things. Integers are whole numbers, 1, 2, 3, dot, 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 0, and negatives, dot, dot, dot. Notice I did not include any fractions, decimals, or portions thereof, okay? These are all numbers that are without a portion. And the final number type that we're going to address today, or that we're going to look at today, is a rational number. Rational numbers includes whole numbers, which includes integers, but add to that fractions or decimals. Okay? So rational numbers are integers, which include 1, 2, 3, 4, 5, but it also includes portions, so decimals. Let's look at this for a second here a little bit further. The number 2.6 with a repeater is what kind of number? There's two answers, by the way. No, there's not. There's one answer. What kind of number is it? What is the only thing that fits that description? A portion. Go ahead, Emma. Rational. Very good. Whereas the number 6, it is a rational number as well. It is a rational integer that is also whole. Or the number -1. It is a rational integer, but it is not whole because it's a negative. So the further in you get, the more specific you get. Whole numbers are numbers you can count and see. Integers include whole numbers, 0, and all the negatives. Rational numbers include everything that you're used to dealing with. Okay? One way rational numbers get described is they say that rational numbers are the quotient of any two integers. So those of you that have your calculators handy, -16 divided by 4.3. What's your answer? Read it to me, honey. Something like that? Yeah. Maybe I cheated a little. Is this a rational number? Yes, it is. Why? Because it is the quotient, that's the division answer, of these two integers. That is an integer, and that is an integer. So even though this is an ugly, goofy looking number, it is considered rational because it is indeed the quotient of these two integers. Now in example 1, they ask us to show that the number given is rational by creating a division problem to explain it. I'm going to show you what I mean by that. Hopefully you're all still with me. This is important stuff. Here's example 1. Show that the numbers are rational by writing a division problem that explains it. Here's what I mean. Take, for example, the number 22. What division problem can I write that would explain it? There's an infinite number of examples that would have 22 as a quotient. Give me one. Sarah. 22 divided by 1, that's a good one. Give me another division problem that would have a quotient of 22. Go ahead, Rach. Yep. Maybe 88 by 4, and on and on. All of these division problems have a quotient of 22. Therefore, 22 is a rational number. What other kind of number is it? Two other things. Not only is it rational, but it is a whole. It's a whole integer. You betcha. It's an integer, and it is whole because it's positive. How about this one? Here's B. Give me some division problems that will result in a negative 15 for a quotient. Sarah's going to take the easy one. Go ahead. Negative 15 divided by 1. How about 15 divided by negative 1? Would that also be acceptable? Any others? Give me one more. I know, keep it simple. Not too hard. Amy, give me another one. She says 30 by negative 2 or negative 30 by positive 2 and on and on. Therefore, negative 15 must be rational. What if I asked you a fraction? Can you prove to me that 10 and 1/2 is rational by creating a division problem? Wow. Okay. Go ahead, Sarah. She's right. If you simply convert this to an improper fraction, that is also a division problem. Improper fractions are, in and of themselves, division problems. You just don't usually think of them that way. This literally means 21 divided by 2. Give me another example that would come up with a quotient of this. Double both pieces and you have another one. Can you double both of these pieces? Go ahead, Al.
42 divided by 4.
Yep, 42 over 4 would also work. How about letter D? Ben, I'm going to let you do this one. Make that into a division problem. I'm giving you a real big hint right now. What does that say? Improper fractions are division problems. Okay? Which we used to create these two division problems from this mixed number. What can you do with this mixed number? Create a what? Go for it. 8 times 2 is 8 times 2 is
16.
okay, times or plus 1. Okay. So it's
17 over 2.
and double it from there if you wanted to make another one. All right. The next thing we're going to do, we're done defining rational numbers. We're now going to go back and review how to take a fraction and convert it to a decimal. Anybody remember the fraction to decimal trick? It's not that bad, I don't think. Emma? Yep. Copy this if you don't already have this. Numerator divided by denominator equals the decimal equivalent. Plug 7/12 in, Stuart, into your calculator. 7 divided by 12. No calculator?
I have it.
No worries. 7 divided by 12. Good. That bar is called a repetant. Very good. He's right. This is the decimal equivalent for 7/12. Gabby, do 5/8 for me if you would. Anytime you are asked to find the decimal equivalent for a fraction, simply take numerator and divide it by denominator. Okay? Numerator divided by denominator. Now, one real quick thing, if it is a mixed number, 1 and say 9/20. Okay? 1 and 9/20. You know your answer is going to be 1 point, whatever this answer is. What's 9/20? Go ahead. Yep. So you don't really need to include that whole number in that process. Okay? Take that 1, transcribe it into the whole numbers, and then divide your numerator by your denominator, and that fills in the remaining portion, okay? Okay. All right, I've got a goofy little word problem that I want to share with you. It's similar to the one with the marsupials, or rodentia, I should say. But we're going to do mine. Here it is. Example 3. At the townhome village, there are 52, I know, I'm sorry to make you copy, but y'all can practice a little penmanship, total rentals, of which 13 are vacant. At the apartment village, there are 148 rentals, with 36 of them currently vacant. At which location is the vacancy rate greater? Vacancy means empty. At which location is the vacancy rate greater? So at Townhome Village, 13 out of 52 are vacant. At the Apartment Village, 36 out of 148 are vacant. Now you can either change them so that they both have the same denominator and compare numerators, or you can do something easier. What do you think would be easier to do, Emma? Decimal. Okay, what's 1352? 1/4? And what's 36 1/48? 0.243. I can stop there. So it looks like at Townhome Village, they're about 25% vacant. And at Apartment Village, they're a little bit less. So it looks to me like TV has a greater vacancy rate. Unfortunately, Townhome Village has a greater vacancy rate. Okay, example 4, that's the last thing we're going to do for today. We're going to do the rest of it tomorrow. Example 4. Example 4 in your textbook has you writing normal decimals, aka terminating decimals into a fraction. So take, for example, 0.6. How would you read that to me, class? And don't say 0.6. Everybody, what does that say? 6/10, which can be quickly written into a fraction with tenths as a denominator. Reduce, please. Always reduce and simplify. 3/5 is right. Or maybe -4.05. If you read that, it's -4 5/100, right? What does 5/100 reduce to? 1/20. Bravo, my friends. Very, very good. So for tomorrow, or for today, you're only doing, you're going 20 through 48, all.